here's part C. This is actually the only part that's Lagrange error. D is actually about understanding what Lagrange error does for you, but C is getting at how do you calculate the Lagrange error. So we're trying to find the maximum possible error. That's keywords. Maximum possible error. That's going to be Lagrange error for the approximation we made in part B. So since we used a third degree polynomial, our error is going to be degree 3. Okay. We're going to evaluate it at some x coordinate. We're going to evaluate the error at some x coordinate. And then we're going to use the fourth derivative at some z value, where z is between x and a. And then we're going to use the 4 factorial, and we're going to use x minus a to the 4th power. Since our polynomial is centered around 3, a is 3, and since we're evaluating our polynomial at 3.7, x is 3.7. So we're going to fill some numbers in. So the other thing we're going to do is we're going to look at this graph here. This is a graph of the fourth derivative, and we would like this to be as big as possible. Well, looking at the fourth derivative graph, the fourth derivative, because it's decreasing on this whole interval, is going to be as big as possible at x equals 3. So the biggest possible value of the fourth derivative will be 6, the y-coordinate given to us here. So if I fill that into my error formula, I'm going to use a 6 for that fourth derivative. Notice how I don't really care that what z is. I really care what is the fourth derivative. What's the biggest fourth derivative? I could have filled in a 3, but really what I want to know is how big can I make that fourth derivative? And the biggest I can make it is 6. And then I'm going to use 4 factorial. And I think I'm off the page. And then I'm going to use 3.7 minus 3 to the 4th power. At this point I would grab a calculator and type that into your calculator, and I get an error of 0.0600 when I do that.